Okay, so today we are going to be looking at equations and patterns. So if you remember back before Christmas break when we talked about the difference between equations and expressions, we said the biggest difference is that an equation has to have an equal sign and expressions do not. So since we're talking about equations, everything we look at today is going to have an equal sign. So when we look at these equations, we're going to be trying to figure out the patterns that are created by this equation. So we're going to take a look at some chairs, which I know sounds weird, but when you take a look around this room, any of the chairs that you guys sit in, so not my teacher chair, and then not a wobble stool, it has to be a physical chair. We're going to take a look at the patterns that we can create using the chairs. So I'm going to ask you some questions, and yes, I do want you to answer them out loud. It's like I'm here, but you're, answering my voice on a video. But if I ask you a question for this next part, please answer it out loud. So let's take a look at some chairs. So first question is, how many chairs do you see? Hopefully you just said one. If you're seeing more than one, we might need to go to the nurse. But yes, there's one chair here. Then the next question is, how many legs do you see? So if there's one chair, we've got 1, 2, 3, 4 legs in total. Now how many chairs do you see? And how many legs do you see? So when we had one chair, there were only 4 legs, but now that there are 2 chairs, we have 8 legs in total. Now how many chairs do you see? How many legs do you see? So if I had one chair, there were 4 legs. 2 chairs, there are 8 legs. And 1, 2, 3 chairs, there are 12 legs. So hopefully we're starting to see a pattern here. So there's a way to write this relationship. It's also called a connection or a pattern between the number of chairs we have and the number of legs in total. So we're going to write this relationship, this pattern, this connection as an equation, so something with an equal sign, but it can also be called a rule. So let's take a look at our notes. Okay, so on our notes, we're going to be starting with this box right here. We'll come back up to the top in just a second, but this box right here. So I've got a left side and a right side. We're going to label the left side as the number of chairs and the right side as the number of legs. So we said when there was one chair, there were 4 legs. When there were 2 chairs, there were 8 legs. And when there were 3 chairs, there were 12 legs. And that's as far as we got. So we need to look for a rule, a pattern, a connection, something between the number of chairs and the number of legs. So I want you to take 5 seconds with the people sitting at your table, decide, how am I going from the number of chairs to the number of legs? Takes 5 seconds, go. All right, so hopefully with your table, you saw that I'm taking the number of chairs and I'm multiplying it by 4 to get the number of legs. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. So what if I said, okay, you have 5 chairs in the room. I'm still taking the number of chairs, I'm multiplying it by 4, and that would give me 5 times 4 would be 20 legs. So I'm going to come up with variables to represent what is happening here. So I'm going to say that my variable for the number of chairs is going to be just the letter C. And the number of legs, I'm actually going to use the letter G because L tends to look like a 1 when we do it by itself. So what I'm doing in order to get G, I'm just going to say that G is equal to, I'm taking the number of chairs and I'm multiplying it by 4. So I would write that as 4C. So what we've created here is an equation. And yes, I've got 2 different variables here. So I have a variable that represents the number of chairs. We said that was C. And a variable that represents the number of legs, which is G. Okay, but I can also kind of rewrite this equation using some very familiar and common variables that are used in all sorts of equations and especially on our graphs. So if you remember where we talked about yesterday when we graph, we have two different axes. We have the x-axis and the y-axis. Well, we didn't talk about a C and a G axis on our graphs, but those variables, remember, you can really pick whatever variable you want when you create an equation. So if I wanted to use X and Y, the number of chairs, that's my X variable, and the number of legs, that's my y variable. So I could rewrite this equation instead of it saying, or this rule, instead of it saying g is equal to 4c, if I wanted to put it in some more familiar variables here, since g is also y, I could write this as y equals 4x, since c is also the same thing as x. So what this is really saying here is I'm taking whatever my x coordinate is, I'm multiplying it by 4, and that gives me my y variable. So this is what we call input output, okay? And we see it in tables, we see it in graphs. We're going to focus really on the tables today. But what's happening here is you're going to input something. So the input goes first. And the input is whatever your x coordinate is. So again, we can take the 1, the 2, the 3, the 5. You can create any number for x. A process is going to happen. The process is our rule down here. So we're multiplying it by 4. And that's going to give us our output, which is whatever the y coordinate is. So I'm inputting the number of chairs. I'm multiplying it by 4, and that's giving us our output, the number of legs. So what if I said, and I want you to answer this question out loud, what if I said my x, my input was 10? So I have 10 chairs. What would be the number of legs? Well, 10, my rule is times 4, so 10 times 4 would give me 40 legs. So this rule that we've created, this g is equal to 4c, what it's done is it's connecting the number of legs and the number of chairs. So again, all we're doing is we're taking the number of chairs that we have, we're multiplying it by 4, and that gives us the number of the legs. So the beautiful thing about equations, about rules, is as long as I have one of the numbers, if I have the number of chairs or if I have the number of legs, I can use this equation to figure out the other variable, the other number. So let's look at two examples. And again, you don't have to write this down. We're just looking up here. So if I go back to my first example, and I know that I have 20 chairs in this room. So in my equation, I'm going to substitute 20 for the number of chairs. So G represents the number of legs, 4 is what I'm multiplying by, and C would become 20 because there are 20 chairs in this room. So in order to figure out the number of legs, all I have to do is 4 times 20, which gives me 80. So I know that there would be 80 legs in this room. But what if I'd had the opposite? What if instead I knew that there were 48 legs in this room, but I didn't know how many chairs? So I'm going to substitute now 48 for the letter G, because again, G represents the number of legs. And then I don't know how many chairs are in this room, so I have to leave it as 4C. So this is just a one-step equation, and we know how to solve these. We build our t-chart. I want to circle what's bothering the x, what's bothering the variable. So in this instance, that's times 4. And then I need to do the opposite. So the opposite would be to divide by 4. And say it with me, what I do to one side, I have to do to the other side. So 48 divided by 4 would give me 12. So I know that there would be 12 chairs in this room. So again, you can take whatever number you have and you can work backwards to figure out what that other missing number should be. So let's create another one. Let's do an example here. What if I wanted to find the relationship between the number of people and the number of legs? So if one person was standing at the front of this room, if there's one person up there, there are 2 legs. Well, then let's say another person or that by one person standing at the front of the room grabs another person. So now there are 2 people at the front of the room. How many legs would there be in total? Well, there would be 4 legs in total. And then the last person grabs another person to come join them. So now there are 3 people standing at the front of the room. How many legs are there in total? There are 6 legs in total. Well, let's say that last person just goes crazy and they bring 4 other people up to the front of the room. So now there are 7 people total up there. Well, if there are 7 people total up there, that means there are how many legs? That's right, there are 14 legs up at the front of the room. And then let's say that person goes crazy and brings, let's say, 8 people to the front of the room. So now there are 15 people standing at the front. How many legs would there be in total? That's right, there'd be 30 legs in total. So what is my rule here? What am I doing? I'm taking the number of people and I'm multiplying it by 2 to get the number of legs. So 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 7 times 2 is 14. And 15 times 2 is 30. So let's create this on our notes. So the things that we were comparing would be the number of people and the number of legs. Okay, so again, I'm going to pick some variables here, and let's just say that the number of people, we'll use P for people, and this time we'll stick with G for legs. So remember, the number of people, that's like our X coordinate. The number of legs, that's like our Y coordinate, because we have to input how many people there are to figure out how many legs that there are in total. So we said if there was 1 person there, but there's only 2 legs. If there were 2 people, then there were 4 legs. Now, let's go crazy. I'm going to change the numbers. Let's say there were 8 people up there. How many legs would there be? There would be 16 legs. And if there were 11 people up there, how many legs would there be? There would be 22 legs. So what we're doing, our process to go from the input to the output is we're multiplying by 2. Each person has 2 legs. So I need to create a rule here, and let's use our variables of G and P. So I'm going to say that my output, G, is equal to my input times 2. So that would be 2P. Again, if I wanted to rewrite this using X and Y, I could say that Y equals 2X. And I'm taking the amount of people and I'm multiplying it by 2, and that's giving me the number of legs. Okay, so looking at our next table, this time I don't have a situation for us. I just flat out gave you the rule. So your rule is C is equal to F plus 2. So first thing we need to do is we need to figure out which variable is the input, which variable is the output. So your input is always going to have something done to it. It's the variable that's getting multiplied, it's getting divided, it's having something added to it or something subtracted to it. So F is having its F plus 2. So the variable F is my input. The output is the result of what you're doing to your input. So the output is C. So let's say my input is the number 1. So I'm going to say F is 1. So I need to replace F with the number 1. So this would just be 1 plus 2 gives me 3. So when F is 1, C is 3. Well, if F is 2, so this will be 2 plus 2, that would give me 4. So again, when F is 2, C is 4. Well, what if F is 5? So I would replace F with 5. That would be 5 plus 2, which would give me 7. Very good. Okay, well, let's say that F is the number 23. So if F is 23, this is 23 plus 2, which would give me 25. And if F was 50, this would be 50 plus 2 would give me 52. So you can see from input to output, every single time I'm just adding 2. So 23 plus 2 is 25. 50 plus 2 is 52. So our next one, we have our rule. G equals N plus 6. So when we look at this, let's label this as our input. This is our output. So which variable, N or G, is the input and which one is the output? Take 10 seconds with the people sitting at your table, decide which one is input, which one is output. Okay, so remember your input is the variable that is having something done to it. So N is having 6 added to it, so my input variable is N. My output variable is G. So I'm going to give you some input numbers, some input coordinates. I'm going to say the first one's 1, 2, 10, 17, 24, and 31. So I want you now, with the people sitting at your table, take the next 30 seconds and, using our equation, using our rule, and using our input coordinates, just come up with what are the correct outputs. Okay, so if my rule is N plus 6, so every single time I'm taking my input, I'm adding 6 to it. So 1 plus 6 would give me an output of 7. 2 plus 6 would give me an output of 8. 10 plus 6 would give me an output of 16. 17 plus 6 would give me an output of 23. 24 plus 6 would give me an output of 30. And 31 plus 6 would give me an output of 37. All right, we're going to do one more. This time, our rule is y is equal to 7x. So label the left side again as your input. The right side is your output. I'm going to give you some input coordinates here. So let's say 1, 2, 4, 6, 9, and 11. So now, with the people sitting at your table, decide which variable is the input, which one is the output, label them as so, and then come up with all your output variables. All right, so we had our familiar variables of x and y. So remember, input is the one that's having something done to it, and x is getting multiplied by 7. So my input is x, my output is y. So 1 times 7 would give me 7. 2 times 7 will give me an output of 14. 4 times 7 is an output of 28. 6 times 7 is an output of 42. 9 times 7 is an output of 63. And 11 times 7 is an output of 77. Okay, so to get your notes into your spiral, yours are a little bit smaller than mine, so let me zoom out. Sorry for the pterodactyl. There we go. So what you're going to do is, with your scissors, and you cannot touch them until I say the magic word. So if you just touch them, put them back in the box. So wait for my magic word. What you're going to do is you're going to take your scissors and you are going to cut as close as you can to your notes without cutting anything off. So remember, it's where we make that L of kind of the white space. So you're going to cut them off as close as you can, and then you are going to get these glued onto page 97 in your spiral. So again, you're going to cut as close as you can without cutting anything off. Page 97, groundhog.